So to add low memory is equal to false. Add low memory is equal to false. Okay. All of you have inputted. Green taxi dear dot info. So we have missing values in various columns. Store and forward flag, rate code ID, passenger count, e-health is completely null. Then payment type, trip type, and congestion surcharge. These have missing values 64, 436. I think common that row has itself missing value. Common rows have missing values. Just check. Let us check one more time. Green deer 1 is equal to green deer dot drop NA. Green taxi deer dot info. Oh, it deleted all. So different cells have different missing values. So we can't drop them. So we have to look at the data and then we have to understand what we can do with this. Okay, so we are missing values. First, what we will do is we will delete this e-health fee, which is completely zero. Okay. Green taxi df is equal to green taxi df dot drop single quote. You can copy the e-health fee, comma, axis is equal to 1. What it says? E-health fee not found in axis. You have to print columns and then take it. Green taxi dear columns. Acha, data type is also there, huh? Then it is correct only. We have to take that, including the data type. Right? We have to take along with the data type. Which one? Here the column name includes data type. Here, like I said, I printed the column names. It includes the data type. Now we have to clean it. We want only the column names. We have to remove that things in the round brackets. That we can do it using that regular expression, re.sub. Resub is there. Like you have G sub in Java, C and all, no? Substitution pattern matching. So we can do that. So we will do that for all the columns. Because it is giving memory error, but for the data, enough memory is not being allocated. So we are giving low memory. See, by default, Python has low memory is equal to 2. It will take as much as possible less memory. Got it, all of you? Okay. Done all of it till here? So first, let us correct, remove the, what you call, data type in parentheses from column name. This you can keep also, but not. If you want, you can keep, or you can remove them. But it's better to remove them because it's a very large names. Green taxi DF dot columns is equal to green taxi DF dot columns dot replace. We have to give the replace double quotes slash parenthesis dot start slash. This is the one we have to give, and we will replace it with space. I've got an error. Index object has no attribute. Replace. Okay, we have to run it as a loop. Because there are multiple things, so what we have to do is we have to run it as a loop. Square bracket x dot replace open bracket double quotes parenthesis, what I gave parenthesis no is equal to slash parenthesis dot star again parenthesis, right?
Yes.
Comma double quotes for once for x in green taxi DF columns. Yeah. Let us check one more time. Green taxi DF dot info. Oh, that's still there. I think we have to use R, we have to give R. On the type. Okay. So string dot replace, we are removing the round parenthesis and all the content within that round parenthesis. And replacing with space. Okay. Hello. ఇస్తాను ఇప్పుడు. Okay, find missing values. E is null dot sum. Got it, all of you? So green taxi deer dot is null dot sum dot sort underscore values ascending is equal to false. So trip type, we have 99,283, congestion charge 9282, store and forward flag 9282, rate code ID, payment type, passenger count. Okay? What happened? So let us go with trip type. What is trip type? Obviously, it will be categorical, right? Or value underscore count. Drop NA is equal to false. So trip type 1 is 61,437. 2 is 2998. So by adding this 9283 to 61, that doesn't make any sense, right? So we will replace green taxi DF dot trip underscore type is equal to green taxi DF dot trip underscore type dot fill NA. We will copy from here 1.0. Just to check whether it worked or not. Yeah, it worked. Okay. The next variable which we have, we will run this one more time to check. Congestion surcharge, numerical will be there. Green taxi DF dot congestion surcharge dot describe. Min is minus 2.75, max is 2.75. Average is 0.74, median is 0. So what should we do here? We'll impute it with 0, median, to be on safe side. Green taxi DF dot congestion surcharge is equal to green taxi DF dot congestion surcharge dot fill NA 0. Just let me check the discovery. Yeah. Fill NA 0. 0 is enough. There is numerical, no? No, I ran describe. You got the values, no? 73.718. Or you can give 0.0 also. No. Okay. 0 as separate category. Yeah?
Yeah, so we're going to do the category, then it's 2 1
Next is what is this store and forward flag ID? Is this store and forward flag? Just let us understand this variable. So this is, see here, data dictionary This flag indicates whether the trip record was held in vehicle memory before sending to vendor. Because the vehicle did not have a connection to the server, y is equal to store and forward, n is equal to not store and forward. So we will use it, value counts. So green taxi DF dot store and forward flag dot value counts for NA is equal to false. Again, we input it with N. Yeah, because 63,680 is already N, so we'll impute it with green taxi DF dot store forward flag is equal to green taxi DF dot store forward flag dot fill NA single quotes capital N. So I'll enter the previous command 72,000 capital N in single quotes. Okay. Next is payment type. Payment type obviously would be categorical. Green taxi DF dot payment type dot fill NA, value counts drop NA is equal to false. So payment type 1 is 41,339. 2 is 22,700. 9 is 328,9282. 326, 69 and 2. So what should we do? Shall we add it to 41,339? Green taxi DF dot payment type is equal to green taxi DF dot payment type dot fill NA 1.0. Let me just go up and remove the missing words. Which one?
Passenger count.
Passenger count would be million.
So median.
Mean or median. Median is the safest, no?
Yeah.
Because median will be round number. Median will be decimal, 2.3 passenger like that we have, no? We don't want that. So we'll use only median.
We are ready to ready. We are replacing the one that passenger count.
Faculty questions.
Water.
How many rate code IDs are there? One second, let me just check one. Passenger count you have already done, right? So green taxi dear dot passenger count dot describe. One, yeah. Green taxi DF dot passenger count is equal to green taxi DF dot passenger count dot will remain 1.0. Green taxi DF dot rate code ID dot value counts drop NA is equal to false. One second, let us read the description. The duration is there, rate code ID, right? This is what, right?
Without underscore, that is an I.
Hmm.
Without underscore.
Rate code. That's- Rate code ID. Hmm. The final rate code in effect at the end of the trip, standard rate, JFK, New York Airport, Nassau, negotiated fare, group ride. So this is the rate codes which are there. So what is the highest? Standard rate. We'll go with standard rate. We'll go with standard rate one, okay? Green taxi DR dot rate is equal to dot fill NA 1.0. So we have cleared all the missing values. Okay. Now, let's work with the dates. Green taxi deer dot head. Now, if you look at the dates, they are in numeric format, number. Actual, what we call it as Unix timestamp. So, green taxi, what is that column name? Numeric date conversion to date time. So, we have to, you type in the straight line. First, we need to convert it into integer. And then divide it by 10 to the power of 6. Then we'll get E plus 09, the time value. Then we'll convert it into date time. Re-import the data and do it, because earlier might have got corrupted. Yeah, Mithun, I'm in a class morning. Tell me, no problem. See, next week, the sessions will be between 5:30 to not even 5:30. Next week, it's not possible. After that week, I'll give you 3 hours, 2 days. Will that be okay? Okay. So that backups and all, we'll cover it on next week. Okay, next to next week, what happens is, I'll give you post lunch some extended 3 hour sessions. You can schedule them. Okay, 2 or 3 days we can do it, so that we can cover 9 to 12 hours like that. Okay. Yes, no problem. Anything is okay with me. Yeah, that's what post lunch only. I am telling you, next week it will be post lunch only. I will reach your campus by 2 o'clock. You can schedule from 2:15 or 2:20 like that till 5 o'clock or 2 to 5. Okay. Got it? Pickup time. So the pickup time starts on 31st May.
Divided by 10 is 6.
10 to the 6. So see, our original date is E plus 15. We need to convert it to E plus 09 because that is a second format. E plus 09 is what it is recognizing. See here. E plus 09 is what it is recognizing. See. See here. Standard conversion epoch time or the real starts with hours, minutes and seconds, which is UTC coordinated inverse. To convert this epoch time into readable datetime format, we will use pandas datetime and we will pass our required column with an unit is equal to s inside the method. Seconds, because nanoseconds also will be there. In server data, we use nanoseconds, milliseconds, nanoseconds will be there. Our 15 is nanoseconds, but we don't need nanoseconds, right? We just need hours and minutes and seconds. So we have divided the date format with 10 to the power of 6 so that we got converted it into E plus 09. Once we convert it to E plus 09, then date time will automatically read it with unit as S and then it will convert it into date time format. So let's do it for the other drop time also. Green taxi df dot L drop off date time is equal to green taxi df dot LPEP drop off date time dot as type int 64 divided by 10 star 6. Okay, same thing, we will convert it to this. Then green taxi df square bracket drop off is equal to PD dot to underscore date time green taxi df dot LPEP drop off date time comma unit is equal to S. So just let me check the head command one more time to check whether the pickup and drop offs are done. 2 columns have been created. Hey, did I use the same time? No, no, pickup date time, drop off date time. Why we got the same times? Pickup and drop off for same time, right? Did I mess up somewhere? S10 64, unit says LPEP drop off date time, I star 26, 64. Drop off date time unit is equal to yes. Yeah, there is no mistake. But values are same. Huh? Values are same in both, right? Because in Excel sheet also values are same. So if I use this from scientific to so Both are same, right? There is no change in the pickup and date time. All are same. No? Hmm. No, 166 is changing. 165 is changing. 166 is changing. So each date will be the same, na? Don't have the problem with the date. We have the problem with time. Time also is coming as 000s, right? Okay, let us go with this only. What will let's not waste time. So this is how we convert the epoch times into normal dates. Okay. Conversion of Unix times. After that, what we will do? One second. Let us do green taxi df dot info. Oh, okay. They are converted into date time, so we don't have any problem with this. See, they have been converted to date time. Pick up and drop the two columns which you have created. They have been converted into date time. Vendor ID we will drop. Rate code ID we will keep. Location ID, drop location IDs we will keep. How many location IDs are there? Just check how many location IDs are there. PU pickup. Two hundred and 42 location IDs are there. We have DO location IDs, drop off location IDs also. We have drop off location IDs of 250. 250, 242 location IDs are there. So we'll keep location IDs or we'll drop them. So what should we do with them? Location IDs? Because some of the location IDs are very big. Some of them are very small. Hmm. So what should we do? We'll keep them or we'll drop them? Because total fair amount will be affected by the drop off and pickup ID, pickup location also. Or we have distance, right? Trip distance is there, then we can drop the IDs, right? When we have trip distance, pickup and drop location IDs can be dropped. So we have the distance, so we don't want that. So we will drop LPEP pickup date time. These two columns we will drop. Vendor ID we will drop. And then we will also drop the location IDs. Okay, these things we will drop. So green taxi dot columns. So that we can copy the variable names. So green taxi df is equal to green taxi df dot drop open bracket square brackets. So vendor ID till drop of location time comma, PU location ID, drop location ID. Comma axis is equal to 1. So we will be. So we'll have dropped these columns. Axis is equal to 1. Okay. Now, using the pickup or date drop off, we will extract some information and we'll drop off those two columns because they are not giving us any information, right? So green taxi DF, double square bracket, dot head 10. So times are all same. Okay, it is not giving us any what you call information where so we use drop off date. Hmm? So green taxi DF square bracket weekday is equal to green taxi DF dot drop off dot DT dot weekday. So we will get the weekday, what weekday it is. Okay. Green taxi DF dot weekday dot value underscore counts. So 0 to 6. 0 being Sunday, 6 being Saturday. So Monday, Tuesday, Wednesday, there are many trips. Wednesday, there is a lot of trips. So we can find the weekdays. So this is 1 month data. So we can't do anything other than weekday. Whether it is Monday, what day it is, we can take. Any other thing we can take? No. Generally, if you have more than 1 month data, We can extract month, we can extract quarters, like that we can do, but this is only 1 month data. So we can't do anything other than weekday extraction. We'll use it as a categorical variable. Then we can drop off the dates. So we will extract information and drop off the dates. Now, can we take difference between two dates? We can't. If hours and minutes and seconds were given to us, then we can calculate the difference in minutes. And then we can take that as a, what you call a trip time. But here we are not getting the hours, minutes, seconds. So we will go with extraction of, now we'll drop the pick up and drop off also. So green taxi df is equal to green taxi df dot drop square bracket pick up and drop off also we will drop, remove them. Comma axis is equal to 1. Okay. Now let us do some group buys. Green taxi df dot trip amount. Trip amount is the variable, right? Total amount. Total amount dot group by green df dot trip type dot mean. So trip type 1, $19.14, trip type 2, $35.19. So we have two different trip types. And then it has 19 and 35. So if you want to do a hypothesis test, what test will you do here? T-test. Test null, the average total underscore amount of different trip types equal. So the means are different. Means are different. So we have to split it. Let us say type 1 is equal to green taxi df square bracket green taxi df dot trip type double equals to 1.0. Same thing, we'll copy paste down. Type 2 is equal to 2.0. From scipy.stats, import test underscore ND. Test underscore end type 1 dot total amount type 2 dot total amount equal underscore var is equal to, so we didn't find the variance. Yeah, the difference in mean is significant. Null. What is the null? No significant difference in average total amount of different trip underscore type. Okay, alternatives, remove the word no. Before significant, it becomes the alternative statement. So any other ANOVA, for ANOVA, we have any small variable? We don't have any small variable for ANOVA, right? So we will do it on weekday. All of you connected the t-test? Test null, the average total underscore amount of different weekday equal. Okay. Green taxi DF dot total amount dot group by green taxi DF dot weekday dot mean. 1934, 1946, 1949, 1976, 2031, 19.97, 20.31.
Is not
Huh?
payment is also that we can go for.
No, we'll do it on weekday. Weekday is a better option, right? So you can create a plot for this also. You can just add dot plot kind is equal to bar. So you can, if you want to do visualizations, SMS would be better option, or dot plot and is equal to bar. You get the bar plot. See? Okay. So you have to give some visualizations and analysis also. Like that one notebook, you forward that notebook to all. The one you checked for there, no? There he has done exploratory analysis. That you can add to your notebook, some of the graphs and all. See, this is how the bar plot will come, weekdays and then the amounts. So means are different, right? So what we have to do, we have to do ANOVA single factor. So WD0 is equal to green taxi DF square bracket green taxi DF dot weekday double equals to 0. I copy paste. WD1 is equal to 1. WD2 is equal to 2. WD3 is equal to 3. WD4 is equal to 4. WD5 is equal to 5. WD6 is equal to 6. I split the data. 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. See, even the small difference in means also is very big difference. Very small difference, no? Yes. That means you can treat them as, no, there is a significant difference. What is null? No significant difference. That means you can treat them equally. That is that statement we are rejecting. We are accepting there is a difference. Because what is null? We are treating them all same. That we are rejecting. We are treating all as equal is null. That we are rejecting. That means the difference is statistically significant. So difference in means is statistically significant. You can't treat them as equal. So we need to have that sort of change in the data, right? Then only we can build model. If you fail to reject null, if you say there is no difference in the data, what is the purpose of building a model? There is no point in analyzing the data, right? If the pattern says there is no change, what does models do? They predict change, right? When there is no change in the data, what is the point of doing predictions and modeling? So first we need to confirm that there is changes happening in the data. Then we will study through models which variables are causing those changes. And accordingly, we will build the models for predictive purposes. Okay, this is on our single factor. Now, PD dot crosstab green date taxi df dot we had different types, right? Yeah, weekday, comma green taxi df dot payment type, right? So, what type of payments on what days? Payment type 1 and 2 maximum, right? Cross tabulations. Now, whether there is a relationship between weekday and payment type. That we will find using chi-square test of independence. Okay, done cross tabulation. So from SciPy dot stats import chi2 underscore contingency. Chi2 underscore contingency. Copy paste the cross tab. VD dot cross tab. Control C. And we will paste it here. Control V. Great. Fail to reject null. That means we are accepting the null. That means there is no relationship between payment types and weekdays. Okay. So we have run some hypothesis test and we found out that the variables are that there is some variation in our data. Now let us look at our variables and split them into object and numeric so that we can label and code object data points. So green data df, green text df dot columns. So object calls is equal to green taxi df double square bracket stored flag id rate code id. We'll take it as object calls. Then payment type, trip type as object calls, and then weekday. Weekday is our what call yeah. So numeric calls is equal to, we just need to drop them. Drop this list will drop it. Okay. And then rest of all we'll take them as comma axis is equal to 1. So we are what we call we have split the data into object calls and numeric calls. Let us print the string. Object calls dot shape print numeric calls dot shape. We'll also print the print tax df dot shape. So 15. 15 means 10 and 5. So we don't have any loss of data. We have correctly done the splitting. So 10 numeric variables, 5 categorical or non-numeric categorical variables. Okay. We do get dummies. Object called dummies. Object calls dummy is equal to pd dot get underscore dummies. Object calls.
Can you please look at that from level?
Hmm?
Label encoding and data tables are same only.
No, label encode will do in the same column.
And database.
Because we have 5 columns, right? Generally, label encode will keep it in 5 columns only, 0 to n levels. But now, if you look at the string, object calls dummy dot share, say 6. I think why 6 only? No, there is some problem. We have to give columns argument. 1 second. Object calls, numeric calls, share. Because they're all numeric data, right? Comma, columns is equal to is the list. Because they're all numeric, na? They're not text. So once we give them the columns is equal to the names, then it will convert them into dummies. If it is text, it automatically converts them. But here we have all numeric data. We have all numeric data. That's why we are giving the column names. Just copy paste the list of the object calls, then we get the dummies. Hmm? Do multi-collinearity test on numericals, calculate the correlation of numeric calls, multi-collinearity.
Why?
Got it? So any multicollinearity? Total amount. So we'll use PLT dot figure fixed size is equal to 15 comma 10. Import C bond as SNS. Import C bond. Why it is saying? You got it right? Max is an error. Think I have to reinstall C bond. Sorry. Exclamation if install C bond. Import C bond as SNS. Oh, still got the error. Cannot import a triple operation. But you guys got the C bond?
Yes.
Then you adjust the plot size. And then SNS dot heat map. And then numeric calls dot CO or NOT is equal to true. You'll get the numbers. So you'll be able to find the variables which
Fair amount, and then the total amount.
all packages are installed, then why it is giving me errors? Okay. Whatever I got. Not able to do C bond here. I don't know what is it. So you have plotted, right? So what are the variables that have multicollinearity? Total amount and paid amount. So we will delete total amount and we'll take paid amount. So that is what finally goes to the driver, right? Fair amount, huh? Then we'll take fair amount, we can delete. Only that variables have multicollinearity. No other variable has, right? So numeric calls is equal to numeric calls dot drop fair underscore amount comma axis is equal to 1. Okay, so total amount is our dependent variable. So green taxi df underscore clean is equal to pp dot concat numeric calls, sorry, square bracket numeric calls comma object calls dummy comma axis is equal to 1. Column concatenation. Acha, you want to do, sorry. Numeric calls dot head. No, they're all in same, na? Not much of a difference. All are in same mathematical units only. There are no big values. Big values means if one column is in hundreds or 200s like that, then we have to do it. If one column is in thousands, one column is in lakhs, then we do scaling. Here, all of them are smaller numbers only. Right, and only one column is in tens. See, total amount. That is anyway our dependent variable. So we don't need to do any standardization or anything is required because all of them are in similar type of mathematical units only. Y is equal to green taxi df underscore clean dot total amount. X is equal to green taxi df dot clean dot total underscore amount comma axis is equal to 1. So y dot plot and is equal to test. Also print y dot q. Print y dot plot. Positive skewness is there, very high positive skewness is there. Because there are some outliers, right? Y dot plot kind is equal to box, comma, what is equal to false. So we have outliers. So the box is onto the left side. So we will try logarithmic transformation. P dot log y dot plot kind is equal to box, comma, what is equal to false. Box moved to the middle, but to some extent it moved to the middle. Right? It moved to some extent to the middle. Somewhat closer to normal distribution. We'll take it as logarithmic transformation. You want to try square root also? NP dot sqrt y dot plot kind is equal to box, comma, what is equal to false. No, no change. Square root is not working because the box is still towards the left. In case of logarithmic, the box is moving to some extent, we have corrected to some extent, not completely. To some extent, we have adjusted the this. So NP log would be a better option rather than NP dot sqrt. Okay. So from sklearn dot linear underscore model import linear regression. Reg is equal to linear regression. Reg model is equal to reg dot fit x comma y. Reg model dot score x comma y 48.85. So it didn't meet the basic R square also. R square must be above 0.60. So reg model 2 is equal to reg dot fit x comma np dot log of y. What happened? Y contains nana. Oh. So log of y is creating some nans divided by 0. So logarithmic transformation we can't do. So reg model is not working on this data, linear regression model, because of the outliers and the all those things. Base models will not work. But we can try the tree-based models. sklearn.tree import decision tree regressor. Tree is equal to decision tree regressor. Tree model is equal to tree dot fit x comma y. remodel dot score x comma y 95.97. See, non-parametric algorithms have a very good performance compared to the parametric algorithm. Linear regression is a parametric algorithm. That means it has assumptions. That assumptions like outliers, closer to normal distribution, these are compulsory. If these assumptions are not met, multiple linear regression will fail. That is what happened. Whereas trees doesn't have those parametric assumptions. They are called non-parametric algorithms. They don't have prior assumptions. They are not bothered about outliers. They are not bothered about the skewness and all those things. So this works. But to check whether there is overfitting or not, model selection, import, Ross val score. We need to check for overfitting. Na? Always in decision tree, check for overfitting. Ross val score 3, comma x, comma y. CV is by default 5. Oh, see, we have a overfitting problem. We have a classic overfitting problem in decision tree. So we will do max depth is equal to 88. Very good. We are getting a negative R square. We are getting a negative R square. So decision tree also has a problem here because we are getting a negative R square. So that is another issue with decision tree. Otherwise, the model seems to be good. Model seems to be good. Similarly, from sklearn dot ensemble, import random forest regressor. RF is equal to random forest regressor n underscore estimators is equal to 3000. RF model is equal to RF dot fit x comma y. We should run fast, so we will get it. So these are the common challenges we face on real-time data sets. Once you get this thing, now, if you are interested in putting this in your GitHub, you can do analysis like tip amount. You can do a tip amount analysis, like which trip type is paying maximum tip amount, in which weekdays tip amounts are coming, where store and flag ID tip amounts are coming. So you have the categorical variables, right? You can group by with those categoricals, and then you'll also try to find correlation between tip amount and total amount. I think already we have found it. You can do like tip amount analysis. Okay, so that way you can also do total amount analysis and then build the regression models. Well, it is running. NYC green taxi analysis 2022. Anybody did?
So you want some class to the video.
Ah. No, you can just upload the IPNB notebook. Once you have done your IPNB notebook, you go to your GitHub account. No, nothing. So what you have to do is, there is login. I already have account. There is login. Sign up is there. Sign in. Actually, I have changed my laptop now, so it is asking for the code again. Yeah. So you can see here, create new repository. Start a new repository, create a new repository, public or private. Okay, your choice. Okay. Repository name you have to give. So say NYC Green Taxi Data Analysis June 2022. Some unique thing you have to give, right? It is a public repository. Okay, create repository. You have created the repository. Now, once you have created the repository, all you have to do is, where is that one? See here, get started by creating a new file or uploading an existing file. Click on uploading on existing file. You can choose the IPNB file, choose your file. You can choose the IPNB file which you have downloaded and you can upload it. See here IPNB file is there now, and then you upload it. It automatically uploads with your outputs, everything, code, notes, everything will be uploaded. Okay, so that way you can just need to create the analysis. Just upload some of the projects, one regression, one classification, one time series like that you upload with all your analysis, some exploratory data analysis and all. Only include those models where you are comfortable to explain. Do not include all models. Okay. If you are including, you tell them, I know I'm multiple linear regression, I know decision tree. I know neural networks, but explaining neural networks will be difficult. Whatever models you are comfortable with, you should be able to explain. Okay. So the EDA, this is very simple. Just create a repository. The repository name must be unique. Repository name should be unique. So just give the new name and then choose your files and upload the IPNB file. Once you upload the IPNB file, it will automatically create and it will be there in the public repository. I should have given 1,000 only. 3,000 is taking a lot of time. So this is what I'm talking about. This guy has seen trip distance. He has worked on trip distance. I think he has done geospatial thing. By pickup hour. Distribution by pickup hour. Right, but we didn't get hours, right? Otherwise, we would have extracted hour and we could also do the trip by pickup hours. So then he has used two airports. How many were two airports, non-airports, predictive model. Say feature engineering, time variables, trip dials. So you can do a lot of analysis. This guy has used geospatial analysis, where based on longitudes and latitudes, no? He has done all those things. And then see correlation, we have used SNS heat map. Numeric variables you have to do. Finally, regression model. Random forest regressor only with an estimate as 100. He got R square of very less R square, how is that? Random forest. Final model is F test. All these things you can just build the models are done. It is run. RF model dot score X comma Y. Okay. So same thing. You have to write some analysis, some interpretations which you can refer to while explaining to the recruiters. Like generally, I see people forgetting hypothesis test statements. Write them, both the statement, null and alternate, so that you can refer to that when you're explaining that project to the recruiters. If you are missing something about doubts in linear regression like assumptions and all, write them there. What are the assumptions? You write them there for your reference only during the explanation process. So once you got this whole process of done, then it will be there. So one student got recent the other day. We did an assessment. They asked him to do a lot of exploratory analysis. They gave him betting data, some betting data. So he has to do month wise, day wise, how many people betted, group wise mostly, then sorting the data, filtering it. Like that, he was asked to do. They gave a set of questions. 10 questions they have given, and based on the questions, he was asked to execute those tasks. So in the first round, we have already downloaded it. So see, complete the task mentioned below. They gave a data file and calculate the time period in days. Okay, find the city and country with highest number of unique customers. Find the unique count of players in country descending order. Which city gives the third highest average first deposit amount? What is the average amount? Plot a graph showing the city and the descending unique of the count of the unique customers. Plot the conversion for each month. They gave the formulas. So these are the variables, and then he started working on it. He has done all except one. He got confused. That's the otherwise he has done the complete. Value counts and group bys only. For exploratory analysis, it's all about group bys and value counts. See what we have done there. So dates, working with dates, like I told you, resample day, month, hour, like that. So here he has to resample the date to month, individual dates to M. M means month on deposit date, and then in months how many the first deposit amounts, and then so he has to do all these things. Then customer lifetime, this median, kurtosis, skewness, customer count. So these type of tasks you will get. And he is also I don't know whether clear the second round, but he's also done the second round assessment also, which is little bit of higher level. They asked him to do customer demographic analysis, bet related. Okay. So they gave him these different betting data types and the questions. Weekly bets, monthly bets, which bet status, cohort analysis means customer behavior analysis. Okay, so heat map only. So he has done this, looking at YouTube video, he has done it, all the amounts and all. So he is hoping that he will get a call Monday for the next level of couldn't solve question 2. So question 2, it's a little bit complicated. I told him we'll do it in the class tomorrow. We'll do it. Touch points. He is not from the marketing background. No, he doesn't understand the marketing thing. So touch points means first channel, first deposit amount, last bet, last deposit. That will be the first and last touch points. So we are planning to work on it in the next session. So Q3 has done, only Q2 he got confused with the words and all. Otherwise, he has completed this thing. So this is how they are sending the data sets to work upon. So 94.18 is the random forest score. I think this would be the best fit model, random forest. And then generally we don't see overfitting in random forest. So we can go with it. And one more model is there, gradient boosting. You can do that. So you can run NYC green taxi data analysis. Reprocessing and regression modeling. Reprocessing, hypothesis testing also. We have done hypothesis testing and regression modeling, rename. Now, file, download as IPNB. Go to GitHub, choose your files, this file, open, uploading files, commit, changes, that's all. You code. Okay. Everything as it is, it will upload. With all your outputs, everything perfectly, it will upload. With your analysis, whatever you write. Got it? So first create repository and then you can upload. So you want me to send a file?